Hello everyone, welcome to this presentation. In this presentation, we are going to explore standard deviation. Standard deviation is one of the measures of variation. First, let's begin with the definition of standard deviation. Standard deviation is the square root of variance, where variance is the average of the square of the distance each value is from the mean. For the population, it is denoted as the lowercase Greek letter sigma, and for the sample, it is denoted as S, the lowercase English alphabet S. So these are the notation for the standard deviation. For population, lowercase sigma, and for sample, it's lowercase s. In a simple language, when we talk about standard deviation, it is the measure of dispersion of the data about mean. How much data is spread about the mean. There are a few things that we need to know when exploring the standard deviation. The first one is the square of the standard deviation is variance. We denote this as sigma square or s squared. Next, the coefficient of variance is s standard deviation, or is the standard deviation divided by the mean. So when you're calculating the coefficient of variance, so the coefficient of variance is the standard deviation divided by mean times 100%, because it is expressed as percentage. If it is for the sample, we have lowercase s for the standard deviation and x bar for the mean. And if it is for the population, we have lowercase sigma over the mu, that is the population mean, times 100%. As a rule of thumb, what we can say is the standard deviation for any distribution is approximately 1/4 of the range. We already know range is the difference between the highest value and the lowest value. When you subtract that and divide it by 4, that is the approximate or the rough estimation of the standard deviation. Okay, let's look at some formulas that we use in the calculation of standard deviation. Okay, first, the population standard deviation. What are the formulas for population standard deviation? If it is the individual series, this is the formula that we use, sigma equal to square root of sum of x minus mean quantity squared over n. And if it is for the group data, sigma is equal to square root of the sum of f times x minus mean squared over n. N is the population size. And for the sample standard deviation, we have the similar formula where the population mean is replaced by sample mean. You can see here. And we denote the standard deviation by s. In population, we divide by the population size n, whereas in case of sample standard deviation, we divide it by n minus 1, sample size minus 1. So these are the 4 formulas that we use in calculating the standard deviation. Now what we are going to do is, we are going to learn how to use each of these formulas. Okay, first example here. Find the population standard deviation, variance, and coefficient of variance for the following data. So they have given the individual series here, and we are talking about the population. Whenever you are calculating the standard deviation, first thing you need to calculate is the mean. So for this data, let's find the mean. Mean is sum of all the observation divided by n. So we add 10, 60, 50, 30, 40, 20, and we divide by how many observations are there. So 1, 2, 3, 4, 5, 6. We divide by 6. We add all these numbers and divide by 6. That will give you the mean. So let's find that mean first. So if you add all these numbers, it is 210. When you divide it by 6, that is 35. That is the mean. Now what we need to do is, we need to make the table so that we can calculate the quantity. We can calculate this quantity, x minus mean quantity squared, because this is the formula for the individual series. We know n is 6. What we need to do is, we need to find the quantity x minus mean squared, and we have to add them together. So Let's make that table. Okay, this is the x value. Now in next column, we are going to find x minus mean. That is 10 minus 35, which is negative 25. Then 60 minus 35, x minus mean, 60 minus 35, that is 25. Next is 50 minus 35, which is 15. And we'll continue and complete this table. Now in next column, we find the square of these numbers. Okay, we'll find the square of these numbers, which we call as x minus mean squared. So the first one is negative 25 squared, that is negative 25 times negative 25, which is positive 625. Next we have 25 times 25, 625. 15 times 15. Okay, next is 15. So 15 times 15 is 225. 225. Now we'll continue and complete this table. Okay, we completed the table. Now let's add all these values. 625 plus 625 plus 225 plus 25 plus 25 plus 225, which is 1750. 1750. Now let's calculate the standard deviation first. So if you recall the standard deviation, okay, standard deviation, the first one, as d standard deviation, and this is the standard deviation for the population, which is sigma, is equal to the square root of sum of x minus mean squared over n. Okay, so that is equal to the square root of the sum of all these values is 1750 divided by n. The population size is 6. Now when you divide this 1750 by 6 and take the square root, it is 17.0783. That is the standard deviation. Next we need to find the variance. Variance is the square of the standard deviation, so it is sigma squared, okay, which is equal to this value, standard deviation is squared, so 17.0783 squared. So if you multiply these this number by itself, or when you square it using calculator, the value is 291.6667. That is the variance. Now the next thing that we are asked to calculate is the coefficient of variance. The coefficient of variance, which we write as CVAR, is equal to standard deviation over mean times 100%. So here the standard deviation is 17.0783. 17.0783 divided by mean. Okay, the mean is 35. Mean is 35 times 100%. So if we simplify this using calculator, the value will be 48.8%. 48.8%. So that is the coefficient of variance for this problem. So this example is for population, and the data given here is the individual series. So we use the first formula. Okay, we use the first formula, That is population standard deviation for individual data. Okay. Now we are going to explore the second example on standard deviation. And here is that problem. For the population, find the population standard deviation, variance, and coefficient of variance for the following set of data. They have given the x value and the frequency. So this is the group data. Let's solve this one. Okay, in this example, first we are going to find the mean for this group data. So you know that in order to find the mean for the group data, we have to make the table with x, f, and f of x. So we have the x value given, which is 2, 4, 6, 8, 10. F is 4, 2, 3, 2, 5. Now let's find f times x. Okay, f times x, which is 2 times 4, that is 8. 4 times 2, 8. 6 times 3, 18. 8 times 2, 16. 10 times 5, 50. Let's add them together because we are in the process of finding the mean first. If we add all frequencies, 4 plus 2 plus 3 plus 2 plus 5, it is 16. Then 8 plus 8 plus 18 plus 16 plus 50 is 100. So once we know this, your mean, this is the population mean, so mu, if you remember the formula, it is sum of f times x over n. Sum of f times x, when we add all these, we got 100. N is the total frequency. When you add all this, we got 16. So 100 divided by 16 is 6.25. Okay, once we have this, in order to find the standard deviation, in next column, you need to find f times x minus mean squared. Now, in order to find the values in the third column, what I'm going to do is, I'm going to use my TI-84 calculator. You can definitely do it without using TI-84 calculator. All you have to do is, from these two, you have to subtract 6.25. From 4, you have to subtract 6.25. And then, in each case, you have to multiply by the frequency. So what I'm going to do is, in order to make my process a little fast, I'm going to use TI-84 calculator. So in list 1, we can plug in the x value. In list 2, we can plug in the frequency. Let's do that. Okay, we have x value in first column, frequency in second column. If you look at our third column, we have f times x. You can also find this using calculator. So if you want to do that, what you have to do is, you have to go to this third column and highlight this L3. So once you highlight this L3, whatever you want to type here will appear here. So what is L3 equal to? What we have in L3 is f times x. Your x is in the first column and f is in the second column. So f times x is L2, okay, list 2 times list 1. So L3 is equal to, if you press second and 2, that is list 2 times list 1. Second and 1 will give you list 1 and enter. You will get these numbers 8, 8, 18, 16, 50. 8, 8, 18, 16, 50. Now we want to fill this one. So all you have to do is go to fourth column, select L4. So let's type this one, F frequency, which is in, this is our first list, L1. This is L2. So frequency is in list 2. So we type list 2, second, and then 2, list 2. Okay, we type here. Actually, we're typing here, but it appears here. Then times, multiplication sign, we have a parenthesis begin. Okay, parenthesis begin x. X is in list 1. This is our x value, which is in list 1. So in place of x, we type L1. So second and then 1, L1. Then we have minus the mean, which we obtain here, 6.25. 6.25. Close the parenthesis, and there is a square sign. Square. Then hit enter. You will get all the values over here. Okay, let's hit enter. So we obtain all those values. So let me write these values here. Okay, after you complete this column, add all the values which are here in this column: 72.25, 10.125, 0.1875, 6.125, and 70.3125. You should get 159. Make sure you check this in your calculator. Okay, now we are ready to use formula and calculate the standard deviation. So let's write the formula for standard deviation. Okay, this is the formula for standard deviation. Now let's plug in the values. We have a square root of sum of f times x minus mean quantity squared, that is 159. N is the total number of observation, that is the sum of all frequencies, which is 16. And if we simplify this using calculator, you should get 3.1524. That is the standard deviation. That is the first thing we are asked to calculate, standard deviation. Next, we need to calculate variance. So let's find that variance, which is the square of the standard deviation, or square of 3.1524. So if we square this, you must get 9.9376. 9376. That's your variance. Next, we want to calculate coefficient of variance, which is equal to sigma over mean. Okay, sigma over mean. In this case, we have the population mean. So we write that as mu times 100%. So multiply this by 100%. Let's plug in the values. Standard deviation, which we obtain up here, that is 3.1524. 3.1524 divided by mean, which we obtain here, 6.25. 6.25, and we multiply by the 100%, which is there. 100%. Now, if we simplify this using calculator, you must get 50.44%. So we use the second formula to compute the standard deviation. So we use this formula and we calculated the standard deviation. In order to calculate the standard deviation here, we take help of calculator to find this value. You can also check your answer using calculator. So we already have the data entered in the calculator here. Now, you go back to the main screen by pressing second and mode. Your data, your everything is stored here. Remember one thing, you have the x value in list 1 and frequency in list 2. So what you have to do is go to stat and then calculate. So that is your calculate, and hit number 1. Okay, enter that. It's already selected. So one variable stats, enter that. Your x value is in list 1. That's good. Frequency is in list 2. Make sure you have L1 here, L2 here, and then calculate. Okay, and remember, we are calculating the population standard deviation, which is sigma. So you can see here, sigma is 3.1524. 3.1524. Also, our mean in this case, okay, mean is 6.25, which we obtained here, 6.25. So you can always verify your answer using your TI-84 calculator. So in these two examples, we work on the standard deviation for population. Now we are going to look at the standard deviation for sample. Okay, third example, find the sample standard deviation, variance, and coefficient of variance for the following set of data. As always, your first step is to calculate the mean of this data. And in order to calculate the mean of this data, you have to add 10, 60, 50, 30, 40, 20, and divide this by 1, 2, 3, 4, 5, 6. You have to divide by 6. So let's first do that. Okay, when you add all these, it is 210. And you're dividing this by 6, which is equal to 35. Now, we need to make the table. So first, we have the x value. Let me write these values in the table. Okay, once you have the x value, in next column, you need x minus mean. That is 10 minus 35, 60 minus 35, 50 minus 35, 30 minus 35, 40 minus 35, and 20 minus 35. So let me write those values. Once we have these values, now in the next column, we need x minus mean squared. First, square of negative 25. Negative 25 times negative 25 is 625. Then we have 25 squared. 25 times 25. 625 again. And then we have 15 times 15, which is 225. So we'll complete this table. Once we have everything here, we are going to add these values. 625 plus 625 plus 225 plus 25 plus 25 plus 225, which is 1750. So our table is ready. Now we are going to use the formula for the standard deviation. In fact, the simple standard deviation S. So let me write that formula. Okay, here is the formula. Standard deviation S is equal to square root of the sum of x minus x bar, the mean, divided by n minus 1. This is the sample standard deviation. So this mean is a sample mean. I also made that correction here. X bar in place of mu, x bar in place of mu, and x bar in place of mu. Okay, let's plug in the values. So your standard deviation is equal to the square root of, if you add all these, it is 1750. And you divide that by n minus 1, the total is 6. 6 minus 1 is 5. And if we simplify this using calculator, 1750 divided by 5, and then square root, your result must be 18.7083. 18.7083. That is the mean. That is the standard deviation, sample standard deviation. You can always verify this work using TI-84 calculator. So let's quickly try that. Okay, in TI-84 calculator, we go to Stat, then Edit, number 1, select that. And in list 1, let's enter the data, 10, 60, 50, 30, 40, and 20. Once we enter the data, go to Stat, then Calculate, and number 1. You have just a list 1 where you have the data. You don't have frequency, so delete this L2 if it is there, then calculate. You'll see that the mean is 35 that we have calculated here, and the sample standard deviation S is 18.7083. So the work that we have done manually matches with the calculator work. Now let's find the variance and coefficient of variance. Now you know that the variance is the square of the standard deviation. So the variance is S squared, which is 18.7083 squared. And if you square that value, you must get 350.0005. Make sure you check that in your calculator. Also, we are asked to find the coefficient of variance, which is given by the formula standard deviation divided by mean times 100%, because this is expressed as percentage. So your S is 18.7083. We are dividing that by mean, which is 35, and we are multiplying by 100 to get the percentage value. If we use calculator to simplify this, you should get 53.45%. That is the coefficient of variance for this problem. Okay, that is the end of this example. We calculated the sample standard deviation, variance, which is S squared. Okay, we calculated the variance, and we calculate the coefficient of variance. Now we are going to look at one more example. Okay, the last example, find the sample standard deviation, variance, and coefficient of variance for the following set of data. So here is the group data given. You have the x value and the frequency. So as always, in the calculation of a standard deviation, we need to find the mean first. So in order to find mean, we need x, f, and fx. So I'm going to make a table for that. Okay, next you need fx, f times x. So we obtain by multiplying 2 times 4, 8, 4 times 2, 8, 6 times 3, 18, 8 times 2, 16, 10 times 5, 50. Now let's find the total. If we add frequencies, all f value, you should get 16. Make sure you check that. If you add f times x, it must be 100. Now you can find the mean. So your mean, which is x bar, because it is for sample, is the sum of f times x divided by n. That is 100 divided by 16. If you divide 100 by 16, you should get 6.25. Now in order to find the standard deviation, in next column, I need f times x minus mean quantity squared. Now in order to find the value on the fourth column here, I'm going to use my TI-84 calculator. In list 1, I'm going to enter the x value. In list 2, I'm going to enter the frequency. Okay, the values are entered, x in list 1 and frequency in list 2. Now if you want to check these values in the third column, you can go to list 3. It is f times x. F is in list 2 and x is in list 1. So it is L2 times L1. So let's type that. Second and 2 will give you L2 times second and 1 will give you L1, and then multiply. And check these values: 8, 8, 18, 16, 50. 8, 8, 18, 16, 50. That's correct. Now let's go to the fourth column or list 4. And here, in order to find these values, highlight this L4 by moving this up arrow so that gets selected. Now you can type f times x minus x bar squared. So the way we do that is f is in list 2. So we type list 2, second and 2 will give you list 2. Then we have times this dot, parenthesis begin, then x. These x values are in list 1. So we write L1 here by pressing second and 1. And then minus x bar, the mean, which is 6.25. 6.25. Close that parenthesis and then square it. And if you hit enter, you'll get all these values, the values in the fourth column. Let's check that. Enter. We have these values. So let me copy those values here. Okay, once we have all these values, let's add them together. 72.25 plus 10.125 plus 0.1875 plus 6.125 plus 70.3125. Do that in your calculator. I got 159. Make sure you check it. Okay, everything is ready in our table. Now all you have to do is we have to use the formula for the standard deviation. Okay, let me write that formula. Okay, that is the formula. Once we have the formula, let's substitute the value. So square root of the sum of f times x minus x bar squared, sum of this one is 159 divided by n minus 1. N is the sum of all these, which is 16, minus 1 is 15. So if we divide that, 159 divided by 15, and if we take the square root, you should get 3.2558. That is the standard deviation. We already have the data in the calculator. Let's check that in our calculator. So what you have to do is you have to go to stat. We already have the data, so we have to go to stat, then calculate, and it's one variable stat, so number 1, and then enter. You have x in list 1. Now frequency is list 2, so press second and 2 to get that frequency, and then calculate. And you'll see that your sample standard deviation is 3.2558. 3.2558. Okay, now let's calculate variance and coefficient of variance. So for variance, you know that the variance is the square of the standard deviation. So it is the square of 3.2558. Okay, if we square that value, you must get 10.6002. That is the variance. Next, we need to find the coefficient of variance, and the formula for the coefficient of variance is the standard deviation divided by mean times 100%, because this is expressed as percentage, which is equal to, our S value here is 3.2558. So we'll write that 3.2558 divided by X bar. The mean is 6.25, and we multiply that by 100%. Now, if we simplify this using calculator, you should get 52.09%. 52.09%. That is the coefficient of variance. Make sure you check those those calculations using calculator. Okay, so that's a long video. We spent a little bit over half an hour, but we cover everything on a standard deviation. Thank you so much for watching this. I hope you find this helpful.